Welcome to your first lesson in Unit 6, Electronegativity. The objective for this lesson is to utilize the periodic table and understanding of periodic trends to determine the degree of electronegativity. All right, so what is electronegativity? Electronegativity is the measurement of the tendency of an atom to attract a bonding pair. So be very particular about this bonding pair. Be very, very careful because these things can get mixed up sometimes. So I'm just going to draw you out an example of a bonding pair. So bonding pair is a pair of electrons that are bonded between an atom and another atom, okay? So let me make these magenta. Okay, I have my other hydrogen. Okay, so our bonding pairs are right here. So this is one bonding pair, and this is another. Okay, so electronegativity is the tendency of an atom to attract a bonding pair of electrons. When I say attraction, I mean that they're pulling the other other atoms' valence electron in. Okay, this is our vocabulary for this lesson. Just go ahead and pause the video now and write these down. Okay, so let's move right on into these periodic trends that affect electronegativity. Okay, so atomic radius is the radius of the entire nuclei and the electron cloud, right? And so, just give me 1 second. All right, let's take boron. It has a larger radius because it has 4 rings. It's 4 rings. 1, 2, sorry, it looks terrible. 3, and then 4. Right, so it has 4 rings. You got 1, 2, 3, 4. Your valence electrons are further away. Your 7th valence electrons are further away from the nuclei, so there's less of a pull. Compared to something like fluorine, which is the most electronegative, it's going to have just 2. And you can see I made this purposely closer. Seven valence electrons, it's really different, very close. So closer, smaller electron radius means more electronegative. As you go down the periodic table, as you'll see next, in the next slide, as you go down the periodic table, through your periods, your electrons increase in number, you see with boron, and therefore the outer shell is further from the nuclei, making it less electronegative. Now, valence shell electrons, the more electrons in the outer shell, the more hungry they are to fill the shell. You can see in this example with fluorine and bromine, sorry, the R there, bromine. On this next slide, here's bromine, it's 2.96. Fluorine is 3.98. So as you go down, you become less electronegative. But what you also see is that bromine is still more electronegative than psyllium up here. I mean sulfur. It's still more because it has, you have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Bromine still in group 7, period 4. Sulfur is period 3. Still not as electronegative as bromine. So as you move from left to right, you become more. As you go from top to bottom, you become less. Okay. All right, recap. Take a picture of that. Recap. The degree of electronegativity depends upon an atom's increasing number of valence electrons and its atomic radii. Like bromine has seven valence electrons. It's a very high number of valence electrons when more has its octet, but it's in the fourth period, so it's a little further away. Compare that to fluorine. Fluorine has right there 7 valence electrons. It's the most, has the tightest radius, so it is going to be the most electronegative atom that we have. All right.